Okay, in this tutorial, we are going to review how to conduct a multivariate analysis of covariance, or a MANCOVA. And we're going to do this with the data set and different age categories and seeing what the relationship between those categories and the number of hours participants worked and their income. And we've decided that we want to control for one covariate. We want to control for a variable in each of these age groups, and that is education. And so when we start our MANCOVA, the first thing we want to think about is our assumptions. And so going into this tutorial, we're going to assume that we have already analyzed our data for the normality assumption, and that we've already looked at scatter plots and maybe a Pearson R for the linearity assumption. And so now we're going to look at the assumptions of homogeneity of variance, covariance, and homogeneity of regression slopes. And we do that by first running a MANCOVA to look specifically at those assumptions. So we're going to start with analyze, general linear model, and multivariate. And here we're going to go ahead and set up our MANCOVA how we will run it later, but then we're going to change the model, and I'll show you how that works. So we're looking at age, and we want to look at age, and our dependent variables here are going to be income and hours worked. And our covariate, remember, is education level. So we have that set up, and then we are going to go into model. And here we're going to create a custom model because, again, we're going to look at specifically the homogeneity of regression slopes, and we do this by seeing if there is an interaction between our covariate and our independent variable. So we're going to put both of these over here, and then I'm going to click this, and I'm going to hit Shift and arrow, so I select both of them and send both of them over. We'll hit Continue here, and I'm going to go into Options, and I want to do my homogeneity tests. So I'm going to go ahead and click there. And we're good. Okay, so when we first let's look at our boxes M, the equality of covariance, and see we want it to be non-significant. And here it is, non-significant, excellent. And we can also look down here at our Levines. We also want it to be non-significant, and we're good here. So we have met our assumption for variance, covariance. And so now we're going to look at our regression slopes, and all we want to look at here is this interaction right here, age by education, and we want to make sure that none of that is significant. And if none of that is significant, then we have met our assumption for homogeneity of regression slopes. And it looks like we have. Awesome. So now we're ready to actually run our MANCOVA. So we're going to go back in, Analyze, General Linear Model, Multivariate, and we have everything set up here. We don't need to change anything, but we do need to go in and change our model. We're going to go back to full factorial, continue here, and we're going to go into our options, and we want descriptive statistics. We also would like some estimates of effect size, and we're going to go ahead and put the display means over here because this will really help us analyze our post-test ANCOVAs. So this looks good, hit continue, and all this looks good. We're going to hit OK. And so now we're looking at our actual MANCOVA. And the first thing it's going to give you is our unadjusted descriptive statistics. So these are unadjusted for your covariate. And then you can look down here and you can see that it's going to give you the adjusted ones based on your covariate. Remember, your covariate is education. So let's look up here, and we want to look and see if we have any significance. And since we have met our assumptions, we can use Wilks lambda here, and we see that we do have significant results here, and that there's a significant relationship with our covariate, and that there are also significant differences in age based on income and hours worked. So we know our overall is significant. Now we're going to go look at the actual separate ANCOVAs. And when we do this, remember, because we're running separate tests, we need to do a Bonferroni correction, and that would be 0.05 divided by 2, which means that we were going to look for significance for anything that is 0.03 or less. But you can see here that we have some significance that are less than 0.03, so we're good. Specifically, we see the significant relationship again between our covariate and income and hours work. But also, this is what's important here, is when we're looking at age, we see that age has a significant influence on income, but age does not have a significant influence on hours worked. So then we want to figure out, well, how exactly does this relationship work? And we look down here and we look at our adjusted means, and we can see that, okay, so if we're looking at age and we know income is significant, we see that as age goes up, so does income. And that is when controlling for the covariate education.